Good morning everyone. Today I'm going to explain you from the D question of finding range and domain of functions. So I'm going to start from the D question. In the previous part 1 video you can find the solution of A, B, C questions. So D is y equals x square by 1 plus x square. We need to find the domain and range of this. Domain are the x values of the given function. So domain is usually denoted by d of f. The denominator is 1 plus x square. 1 plus x square cannot become 0 for any values of x, isn't it? No values of x can make 1 plus x square 0 because x square is positive. Adding 1 to that, it remains positive. So no values of x can make 1 plus x square positive. Therefore, domain equals to all real number. Domain is all real number here. Now what is the range? What is the range of the function? To find the range, let's write the question once again. Y is equal to x square by 1 plus x square. Take the denominator to the other side as there is no simplification left to do here. So 1 plus x square into y equals to x square. So you get y into x square y equals to x square. So we get x square y minus x square equals to minus y, or x square times of y minus 1 equals to minus y, which we can take it as x square equal to y by 1 minus y, isn't it? Implies x is equal to root over y by 1 minus y. Now, considering x by root over y by 1 minus y as a separate function, alright, as a separate function. So, the real number line for y, minus infinity to infinity. The points we take is 0 and 1, isn't it? Now let's take arbitrary values and substitute in this. If I take x as any value over here, say x is equal to minus 1, y equal to minus 1, not x, y equals to minus 1, x will be root over minus 1 by 1 minus of minus 1. So that will be root of minus 1 by 2. So that's negative. Negative roots are not part of real numbers, they're complex number. So I cannot let y here. I cannot have y values between minus infinity and 0. Now let's take any value between 0 to 1. So let's go for 0.5, which is 1 by 2. So there you get x is equal to root over 1 by 2 by 1 minus 1 by 2. So that's root over 1 by 2 by 1 by 2. So that's root 1. So that's basically positive. Positive or negative. So therefore, this is accepted. I can consider y values between 0 and 1. Then let's go for any random value between 1 to infinity. Say you're going for x is equal to 1.5. What do you get? Y equal to, not x, y equals to. So x is equals root over 1.5 by 1 minus 1.5. Both the numerator is positive, denominator will be negative, minus 0.5, isn't it? Hence, the end answer is negative here. So I cannot admit y here. So y should be between 0 and 1, right? Y should be between 0 and 1. Should I include 0? With this we come to know that y y is equal to 0 to 1, or y should belongs to 0 to 1. Now, should I include 0 or 1 or both? Well, that depends on what the function is. The function is y by 1 minus y. I can include 0 because if I consider y as 0, only the numerator is 0, denominator will be 1. If I consider y as 1, the numerator will be 1, denominator will be 0. So I can include 0. So I'm going to put a closed bracket here and open bracket over here. Alright, so that means I'm basically excluding 1 from the range value. The 1 cannot be the range values. So y belongs to 0, 1, including 0, excluding 1. Right? But let's have one thing in mind. Y belongs to this. But what is y basically? Y is the answer of x, isn't it? So before you exclude a number, make yourself sure that no value of x should give you y as 1. You understand what I'm trying to tell you? Y belongs to 0, 1. Absolutely fine, because this is where we got that from. But the y are the answers of x, right? Now, when we say the range should satisfy the domain. So, can there be an x value that can give 1 as the y value? Or substitute y as 1 in the question and check whether can there be any x value, because you defined x as all real numbers. Alright, now let's do that and verify. If y is 1, this is all your working, okay, rough. You don't need to show in your fair working. If y equals 1, though we haven't included, if y is 1, my function is y equals, what is the function? X square, let me check once again. X square by 1 plus x square. X square by 1 plus x square. We defined the domain as all real number. Now, before we conclude the range, we need to be very sure whether what we excluded is actually right or not. So I'm considering y as 1. So I get x square by 1 plus x square. So I get 1 plus x square is equal to x square. Does it make sense, isn't it? X square gets 0, I get 1 equal to 0. 1 can't be equal to 0, right? So therefore, y equal to 1 does not give you any fair value of x. That belongs to the domain set. Hence, the range of the function. The range is 0, 1. Close the same bracket. So whatever we said for y, that will be the range of the function also. So I am repeating this once again. Before we exclude a number in the range, we need to be sure whether that is actually not an answer for any x value. So for that, what you have to do? Take that y value that you omitted, apply that in the place of y in the function. See whether that leads you to any valid x value, which is already there in the domain. If it's there, then you should not exclude 1. If it's not there, then you can exclude 1. Hope you have understood. Let's move on to the next question. So we finished the D sum. Now we are heading towards the E1. E question. Y equals 3 by 2 minus x square. 3 by 2 minus x square. What is domain? Domain will be all the ones except the ones that makes the denominator 0, isn't it? So 2 minus x square not equal to 0. So x square not equal to 2. So x must not be equal to plus or minus root 2. So domain here is all real value except set root 2 comma minus root 2. Got it? So that's domain. Now let's start the range. Every time you might find me repeating the same statement, but this is the most important part and most of you find this complicated area. Y are the range values. So once you change the question in terms of Y, you treat it as a separate sum in your mind, and you find the set where the Y belong. But at the end, you need to verify that with the domain value. So Y is 3 by 2 minus x square. I have nothing to simplify, so I take the denominator to the other side. So y times 2 minus x square equals to 3. With that, I get 2y, 2y minus 3 by y equals to x square. Hope you understood the step that I did. 2y minus x square, y I brought it to the other side. Then I took the 3 to the other side, just grouping the terms. Okay. So x square equals to 2y minus 3 by y. So x is equal to root over 2y minus 3 by y. Again root, just like the previous sum. Let's draw a real number line for this. Real number line minus infinity to infinity. In that I'm going to plot 0 and 3 by 2. 0 and 3 by 2. Now take arbitrary values for y. Take arbitrary values for y. In first case, let y be any number between minus infinity to 0. Let it be minus 0.5. Substitute here and see what happens. You will find it is positive. And now take arbitrary value between 0 to 1.5. Let's take y as 0.5 or 1 by 2. You will find it's negative here. And then take a value between 3 by 2 and infinity. Any arbitrary value. Alright. So let's consider y as 2. Substitute in it. So you will find it's positive. We only want that y value in which root over 2y minus 3 by y is positive, because root over 2y minus 3 by y must be greater than 0. Isn't it greater than or equal to 0? Now, so we decided that y should belong to minus infinity to 0 union 3 by 2 to infinity. Now, should I include the 0 or 3 by 2 or both? Well, that depends on this one. I have y in the denominator, so that means y equal to 0. I'll not exclude this. I will be excluding 0, but I'll include 3 by 2. So y belongs to step by step working, okay? Minus infinity to 0 union closed bracket 3 by 2 comma infinity. Alright. Now, what is the value that we particularly excluded here? We excluded 0 from y. Now think about, can there be any x value that can give y as 0? Can there be any x value that can give y as 0? For that, what do we do? We substitute y in the question. Y is 3 by 2 minus x square. If I substitute y as 0, what do I get? I get 0 equals to 3. That's complete nonsense, isn't it? 0 not equal to 3. Hence, there cannot be any x value that can give y as 0, right? Hence, the range of the function is minus infinity to 0 union 3 by 2 comma infinity. Understood? So first we write what y is, and then from y we confirm that is the range of the function. So we finished till the E sum. Now we are heading towards F question. Y equals x by 1 plus x square. Domain will be all the numbers except the ones that makes the denominator 0. It's 1 plus x square, so no value of x can make it 0. Hence, domain is all real numbers here. Right? Domain is R. Now let's do the range function. To start with range, as there is nothing to simplify, take the denominator to the other side. So y times 1 plus x square equals to x. We get y plus x square y equals to x. So here it is not possible to express x in terms of y as we normally do in the other one. Instead we get a quadratic equation. Isn't it? We get a quadratic equation now. So x square y minus x plus y equal to 0 is in the form of ax square plus bx plus c equal to 0. So that means a is y, b is minus 1 and c is also 1. What is the quadratic formula? X equals minus b plus or minus root over b square minus 4ac upon 2a. Right? So apply this ABC values in the formula. You will come to know that it is 1 plus or minus root over 1 minus 4y square by 2y. Now this is how we express x in terms of y here. Now again let's proceed with the number line way. We get root over 1 minus 4y square should not be negative, right? Root over 1 minus 4y square should be greater than or equal to 0. So 4y square minus 1, it should be less than or equal to 0. So that means the critical point I get here is y is equal to minus 1 by 2 and plus 1 by 2. Because 4y square minus 1 if I equate to 0. Y square equals to 1 by 4. Y equal to plus or minus 1 by 2. Isn't it? So let's drop that in the number line along with the denominator 0. So minus infinity to infinity, we take minus 1 by 2 and 1 by 2 also 0. Alright. Now let's see what happens here. Take arbitrary values for y between this interval. So what is it? Minus infinity to minus 0.5. So let's go for x is equal to minus 0. Y is equal to minus 0.7 and see what happens. Then consider x here as well as here. And then from here to here. But I'll show this in a different color. You will find that it's positive throughout this interval and it's negative here, it's negative over here also. So it's negative, positive and negative. So therefore y should belong to minus half comma half. Now the reason why I don't include 0 because when I say interval minus half to half, 0 is already part of it. Point number 2 is can I include that or should I put it in open bracket? Definitely I can include because the number, if I take 1 by 2 or minus 1 by 2, I put it over here and I get only 0. So that's valid, alright. So I can take the end values here. Minus 1 by 2 and 1 by 2 is included. Clear? So range is minus 1 by 2 to 1 by 2. Alright. Now listen. Y belongs to minus 1 by 2 to 1 by 2. That includes 0 also, isn't it? So if I consider 0, this will become 0. If I consider y as 0, y equal to 0, this will become 0. And if this is 0, x is equal to undefined, right? Isn't it? So then I should say that y is minus half to half except 0, isn't it? Taking this into consideration, that is what I should say. But what are y? Y are the range values of the function. So can there be an x value that can give y as 0? Yes. Can there be an x value that can give y as 0? The function was x by 1 plus x square. Isn't it? The function was x by 1 plus x square. Now, if I consider y as 0, it is x by 1 plus x square. So I get x is equal to 0. 0 is part of the real number only. So when x is 0, I get y as 0. So there is no way I can leave 0, or I can say range is all set, all elements between minus half to half except 0. Isn't it? Because there is a x value 0 that can give y as 0. So range is minus half to half, including 0. When we say minus half to half, 0 is already part of it. When we say minus half to half except singleton set 0, that means we are excluding 0. So once you find for y, we need to cross check whether any value that we particularly leave can be an x value, can give a corresponding x value, or any x value can give that particular y value that we are excluding. Only after confirming that you should give your answer of range. Alright, let's move on to the next question. So next is the G question. Y equals x square minus x plus 1 divided by x square plus x plus 1. Let's discuss the domain. Domain will be all the ones that doesn't make the denominator 0, right or not? So can there be anything that makes x square plus x plus 1 equal to 0? Let's check. Being a quadratic equation, I like to check the discriminant here. B square minus 4ac. So what do we get? I get 1 minus 4 into 1 into 1. So that means minus 3, which is less than 0. So no real roots. Isn't it? No real root exists. So that means no real value for x. So that means no value of x can, therefore, no value of x can make x square plus x plus 1 is equal to 0 for any values of x. Therefore, domain is all real number here. Isn't it? X can occupy any value because none of the values in real number system can make the denominator 0. Right? Now let's go to the range. Range of the function. Range y equals x square minus x plus 1 by x square plus x plus 1. Now, again I'm saying, try to simplify if it is possible. Imagine if these were two quadratic equations which has some common factors. Then please factorize, cancel the common factor and then find the range. Otherwise, if you can't cancel, then only you should take the denominator to the left side. Don't forget this. So in some sums, ma'am can simplify. In some sums, ma'am will not simplify. You should not get such doubt. It's mainly because here simplification is not possible. That is the reason we take the denominator to the other side. Y times x square plus x plus 1 is equals x square minus x plus 1. Okay guys, now let's group the terms so that we know that this is going to get us to a quadratic equation. So x square into y minus 1 plus x into x plus 1 plus y into y minus 1 equals to 0. Hope my kids can know to do this, isn't it? So we just group the terms such a way we get it in this form. X square into y minus 1, which means I'm grouping x square with x square y, then minus x with xy, then y and 1. All right. So, yeah. Now, again, it's a quadratic, so we have to use the quadratic formula. X equals, you all know that, so I'm not writing it again, minus y plus 1 plus or minus root over y plus 1 the whole square minus 4 into y minus 1 into y minus 1 by 2 times y minus 1. So that will take us to minus of y plus 1 plus or minus root over y plus 1 the whole square minus 4 into y minus 1 the whole square by 2 into y minus 1. Right? Alright. Now expand the terms that is inside the root. So you get minus of y plus 1 plus or minus root over minus 3y square plus 10y minus 3 by 2 times y minus 1. Now minus 3y square plus 10y minus 3 should be greater than or equal to 0 because it is inside the root, right? Implies that y square minus 10y plus 3 must be less than or equal to 0. Inequality will reverse when you multiply by minus on both sides. Yes or no? Then if you factorize that, you get y plus 1 by 3 into y minus 3 lesser than or equal to 0. Now we need to take a set where y gives us an answer whose product of this is lesser than 0. Draw a number line as usual, minus infinity to infinity. Plot the critical point, minus 1 by 3 and 3, and of course you get 1 also. Alright, now as usual take random values like we've been. I'm not going to do that. I know you people can do it comfortably. Take this analytical table, you have to do it as part of your rough working. You don't need to show in the fair working, but in the rough try to show it properly. So taking random values, you'll come to know that between minus 1 by 3 to 3, you will come to know that the values are positive. Between minus 1 by 3 to 3, you will find it is positive, which means between this and this. So, I have taken arbitrary value between minus 1 by 3 to 1, and then any arbitrary value between 1 to 3, and I'm finding both positive. So, entire limit of that is positive. Now, between minus infinity to minus 3, it's negative. Over here also negative. So, naturally, where does y belong? Y belong to minus 1 by 3, comma 3. Should I include 0? Should I include 1? No. If I include 1, denominator will become 0. That means x becomes undefined. Chalo. Let's say that this is excluding 1. Now, can there be an x value that can give y as 1? Isn't it? Before we finalize that this is the range for the question, range are the y values of the given function. So can there be an x value that can give y as 1? How do we check that? Substitute y as 1 in the function and see whether you get any x value for that. So what is the function? Y is equal to x square minus x plus 1 divided by x square plus x plus 1. If y was 1, You get 1 into x square plus x plus 1 equal to x square minus x plus 1. If y was 1, I'll substitute 1 and I'll take the term to the other side. So I get x square get cancelled. Isn't it? 1 will get cancelled. You get plus x is equal to minus x. So that means 2x is equal to 0. So that means x is 0. So when x is 0, y is 1. So there is no point in leaving z is 1 as from the range. So range of the function is minus 1 by 3 to 3. So we cannot leave 1. All these analysis is for your understanding. What matters is only this. The marks are awarded only for that. So the last sum in today's class, h y is equal to 4 minus x by x minus 4. 4 minus x, x minus 4. Alright. Now, 4 minus x by x minus 4, what is the domain? I think you can say this, right? Domain is all real number except 4. I'm writing it straight away without any steps. Because 4 minus x minus 4 is not equal to 0, x not equal to x minus 4 not equal to 0, x not equal to 4, real number other than 4. Range equals 4 minus x by x minus 4. Can I simplify this? Of course I can simplify this. The previous all sums there was no scope to simplify. So we had to take it to the left side. We have to take it to the left side and multiply with y. Here I can simplify. So what will be the simplification of 4 minus x by x minus 4? It's 4 minus x minus of 4 minus x. So if I cancel, the answer is minus 1. Alright, so y equals to minus 1. So what does that mean? The range of the function is just minus 1 here. So whatever x value you take, any x value, decimals, fractions, integers, anything you take, the answer will just be minus 1 for this. Remember the type of questions. It's a minus x by x minus a. Well, I'd like to add one more question to this, G. I, which is y equals x square minus 9 by x minus 3. Alright, this one. Now what is the domain of this? All real number except 3. Right? Now what is the range of this? Y equals x square minus 9 by x plus 3. Can there be x minus 3? Can there be any simplifications to this? Yes, of course. I can write x square minus 9 as x plus 3 into x minus 3 divided by x minus 3. X minus 3 get cancelled. We get y equals to x plus 3. So naturally y will belong to all real number. No doubt about it. But we have excluded a particular number in the domain. We said domain is all real number except 3. So when I don't take 3 as x, there is no chance of getting 6 as y. Because when x is 3, y is equal to x plus 3. So that means y is equal to 6. So when I'm excluding 3, I have no chance of saying that domain is all real number. Domain will be what? All real number, range will be what? All real number except 6. Okay. Since I'm excluding 3 from the domain, I have no scope to get the relevant y value which I get when I substitute x as 3 in the function. When x is 3, y is 6. There is no chance of getting 6 because I'm excluding 3. So range is not real number. Range is real number except 6. So these are the type 1 questions of finding domain and range in functions. Hope you all understood this. Watch this video again and again to make yourself clear. This covers all the models of type 1.
Thank you.